Uh, so we'll begin today's lecture with literature searching, and I'm sure many of you have done literature searching before for one reason or another. And these days, obviously, we do literature searching 99.9% online. We rarely go to the libraries. As for example, even 20 years ago, you would actually go to the physical library, get a journal, and you would actually read it. So online searching obviously revolutionized everything you can do with searching, and it's a fantastic thing. There are quite a few different engines how you can perform online searching for literature publications, whether they're scientific or whether they're related to arts or other types of activities. So with respect to the scientific literature searching, the reason why we emphasize it during this class, it's extremely crucial for the proposal writing. We usually go through quite a bit of literature before we try to conceive the ideas, and we go through sometimes through quite a bit of literature during the time when we write the proposals. Why? Because sometimes the hypothesis that you had may require some additional polishing, or you may need to find out the details about some techniques, or you may need to find out some more technical information. So there are, I guess what I'm trying to say, there are many reasons why you would be actively looking for peer-reviewed or non-peer-reviewed literature while you're working on the proposal, whether this is happening before you start working on it formally, or whether you're in the active phase of the development writing, and so on and so forth. So again, why do we do this? We would really like to know what has been done before us. So again, in the context of the proposal writing, please don't propose this exact same thing if it has already been done before. So although it may sound like an obvious thing, but quite a few times you may be able to find an exact paper on a project that you're trying to think about. So again, be mindful of that, and again, try to do some searching with a relationship to your proposal to make sure that you're not repeating somebody else's work which has already been done. So another reason why we obviously perform literature search is to learn information about feasibility and methods for research strategy. We tend not to propose the methods that work poorly or irreproducibly. On the other end of the spectrum, in case if you find out that there is this technique which is highly scalable, low cost, high throughput, that's likely what you should be proposing as a method for your research strategy, because once the proposal is going to be reviewed by your peers or by the review panel, they would definitely appreciate that the method that you're proposing for your work is indeed feasible, is indeed scalable, and so on and so forth. Another reason why we do literature searching is, again, to learn about the cutting edge research that is undergoing and future directions. So again, depending on the goal for your literature search, you would either look for original papers. So in case if you're interested in, like, what's the state of the art? Well, you try to look for big names, for big publications, which has been published in the recent 2 to 3 years, and you would be able to figure out what it is. So during this lecture, I will show you the tools of how to find it, how to find the top papers in the field, and also how to find, for example, top reviews in the field, or I should say most impactful reviews in the field. Another reason why we perform literature searching is, again, to conceptualize the research idea. In other words, trying to figure out where does the field in which you're trying to write the proposal currently stand. So again, what you would like to avoid, proposing something which has been very well established, not necessarily as a technique, but really, for example, something, let's say you're trying to figure out protein structure. So in case if you're trying to propose technology development in the area of, let's say, NMR spectroscopy, well, this is a very well-established technique. You probably should not be doing this. On the other hand, in case if you're using it as a tool, you do want to use a tool which has been very established to solve perhaps a very cool problem or a problem that nobody has thought before. So again, depending on what you're trying to accomplish uh, and how you would like to conceptualize your research area, it's important to read literature. It's important to search literature. It's important to find the right literature. Again, literature does provide us with methodologies that produce specific results. And also what's really important is previously reported applications. So again, in case if you're trying to propose that you would be able to, let's say, find out or figure out the structure of protein X, in case if similar structures have been studied by similar methods, it's very unlikely that this is a very unique project unless the application that you're trying to develop, or unless the impact of that particular protein that you're looking after is going to be ginormous. So again, this is the reason why it's important to read the literature, to read both the original literature and also the derivative literature in the form of reviews and mini reviews. So there are different levels or different tiers of literature searches that I distinguish. So level 1 searches, they're like very basic and very quick searches. They're very broad. So this is something that you do, for example, by Googling things out. So these may not necessarily be super reliable sources, and they will likely not going to be peer reviewed, but they're very easy to access. They're very easy to get to. And the examples of these searches, for example, again, just using Google as Google itself by Googling it. And also, for example, using free sources such as, for example, Wikipedia, which can provide you plethora of very useful, detailed, very well-established information, which has been ironed out by ages. So things of the nature of looking up a very quick structure of a compound, looking three-dimensional structure of a compound, boiling point, melting points, molecular weights, things of that nature. This is very, very handy. Or looking for established methods of production of some chemicals. Again, something which is very handy. And then there are level 2 searches that we tend to distinguish. These are more in-depth searches. These are very, in here we're looking for very specialized information. We would like to be able to get into the nitty-gritty details during this level 2 searching. And here we're typically looking for peer-reviewed and copyrighted materials. So again, because they're copyrighted, they would cost money to get to them. And again, because we work at Wayne State, Wayne provides a lot of resources to be able to perform literature searching extremely effectively. So this information, again, is more difficult to reach, and we will review several different sources or several different platforms for literature searching today. In some cases, they require subscriptions. So again, just getting through that barrier could be slightly more dramatic, but in some cases, or I should say most cases, it's well worth the barrier. The examples of these platforms are, for example, ScienceFinder, established by ICS, PubMed, established by National Institute of Health, Web of Science, which is at the moment is a private entity, Google Scholar, Scopus, and some others. So these are very useful platforms for specialized information and for cutting-edge developments in science and technology. These are the things that, in case if you try to Google, you may not necessarily be able to access. The most you can probably access is some information such as, for example, abstracts. So with this, I'd like to kind of go over some of the examples. So this is an example of a Google search. So for example, in case if I'm interested in choline, broadly speaking, I can just Google for choline and I'll be able to come up with all kinds of information. So for example, here I see some images of what choline can be, is typically associated for people searching online, and this may be related to the food supplements. It may be related to some other things. And quite often, you would also see a link to Wikipedia. So again, if you click that link on the Wikipedia, or if you go to Wikipedia as your primary source and perform search in the Wikipedia window, you would be able to get to a record of choline, which is a chemical compound. And again, this is something that you can do extremely quickly, and you would be able to find out the structure of choline, three-dimensional structure, and some other information, which is a very established general information. So again, if you're trying to learn something, this is very quick and easy tool to get this broad knowledge. So I would actually like to skip through this slide for the time being. Excuse me, yeah. So with respect to literature reading goals, there are several reasons, or there are several goals that we're trying to go after, and they're related to search as well. So they basically go hand in hand, searching and reading. So from the perspective of reading goals, we would like to be able to extract pertinent information from a paper. So again, level of depth depending on how meaningful the work is to you. And sometimes you would like to skim through a paper rather quickly, perhaps look at the key figures, but to be able to do this in a meaningful way, you need to be able to get access to that PDF. So again, being able to get access to this PDF, we'll review it a little bit later during this presentation. So we'll go through some of the tools and we'll try using some of the tools, such as, for example, Google Scholar. We'll use the tools of the Web of Science to be able to find the information that you need. So you can also very quickly skim through abstracts and conclusions, and they provide the key goals and summary of the results for a particular paper. You can also look up at the discussion, and that will provide the discussion on the data and the interpretation. And also the method sections will provide the description of what was done, how it was done, and the tools that were used. So again, these are the reasons why we search for the literature. So the first engine that we will briefly discuss is SciFinder. Again, this is the platform which has been developed by the division of ICS. This is effectively a chemical abstract service. To be able to use this service, you will need to create an account with SciFinder. And you can go through Wayne State Chemistry Library to get to SciFinder. You can search various items, such as, for example, scientific topics, authors, specific journal citations. And one of the things that I should emphasize is we as a university pay for the subscription service, which you can then use through the library to get the information that you need. Another resource which is quite useful and which I use probably more than many other resources is Web of Science. So again, in the context of this presentation, I provide the direct link to the Web of Science. Web of Science platform provides access to resources in all kinds of things, including science, social sciences, humanities. Combined, it supports 256 disciplines, well beyond science. So as you can see, for example, in case if you're trying to compare this platform to the previous platform which we discussed, this is a very, very broad platform, yet you can find the PDFs of the papers, you can find the very nitty-gritty level of details. Web of Science currently covers 1900 and after, so quite a few years of scientific records. Combined, there are more than 159 million records available through Web of Science, which is quite remarkable, and more than 1.7 billion of abstracts or references that it can actually search through. So the record depth goes with citation indexing, author information, topic title, subject keywords. You can it does perform search through the abstract, which is fantastic. It screens through a lot of different things. Periodical titles, author addresses, things of that nature, and obviously publication years. You don't need an account to be able to use Web of Science if you go through the university gateway, and I will do a demo of that. But having an account can be very handy in case if you are already working with records in the Web of Science. And again, I will do a demo describing what we mean by that. So to be able to go and access Web of Science, we have, especially now during the time of the coronavirus, Wayne State University provides a link to be able to do it, and this is exactly what we will try to use now. So I will copy and paste this link. Ta-da! So once you're going to go to this link, you will be able to access Web of Science through Wayne State University, which is fantastic. If you go directly, so it will obviously ask you for your login information. So I'll click send, and now the system lets me in. This is the window that you will actually see when you log in. And what's really important here is this field. This is a basic search area. Here you have different fields which kind of tell you or define your search. We have a time span. So typically I try to keep it like to all years possible. So again, because we were interested in, for example, things like choline, I will type choline here in my main area of interest. So
Ed, are you expecting us to see what you're doing online?
Oh my God, you're not seeing it. I apologize.
Yeah, no problem. I think it's early enough, but I just caught it.
Right, because of how the sharing works. So just give me 1 second. Yeah, let me stop the share and let me actually do another share. Do you see Web of Science screen? Okay, fantastic. So I will actually gonna go 2 steps back. So I'm actually gonna go here. So this is the link that I posted in the PowerPoint slide. So this actually takes you to a Wayne State resource, and here you have a link to the Web of Science. So that's where you actually click on the Web of Science, and that's going to pop up its own window. And the thing that you didn't see is Wayne State Gateway will actually ask you for your login information. So it's not really available to everyone. You have to be affiliated with Wayne State University to be able to use Wayne State resources to be able to access Web of Science, because it's a paid subscription. Wayne, we pay for it. It's a fantastic resource. I cannot overemphasize the value of this resource. So now when you can actually see it, you will see here that there are several different fields. There is a time span field. So I usually try to keep this through the entire time span available through the Web of Science. And again, the topic that we were interested in, it was a choline. So I'm going to type here choline as an example of the search. And here I will add a search. I will try to narrow it down. I will put NMR spectroscopy. And this will be another topic. And now I will hit search. So now the search has been performed. I was able to come up with almost 2,000 results. It's important to know how many results you were able to come up with before you start reviewing anything. In case if you came up with many results, it may not necessarily be meaningful to look for the things that you would like to see. And then there are particular very helpful tools which are available here, which I will discuss briefly. First of all, what you can do, you can actually hit this button, which is called Analyze Results. And what it will do, it will actually tell you the fields and the areas which are associated with the results that we were able to identify. So it turned out that when we were searching for choline and NMR spectroscopy, this was was very largely related to radiology and nuclear medicine, nuclear magnetic resonance imaging, not surprisingly spectroscopy, but spectroscopy turned out to be not the most important thing. So why this is important? Well, in case if you're performing your search, it can actually tell you where the keywords that you've been looking for have the most value. So for example, in case of, if let's say you were trying to draft a proposal which was related to biophysics, you can actually hit view these records. And as a result of that, Web of Science will narrow down your search only to the records related to biophysics, which is very helpful because you do want to get to the papers, to the information that you would like to have. So we're gonna rewind back a few slides. So I will also discuss a few other very helpful tools. So how would you know which papers are the most impactful? Well, luckily there are these interesting tools here. So for example, you can hit on what we call highly cited in field tick mark, and then we're gonna refine the search. So what highly cited means, these are the papers which are basically like top 1% papers in the field. So again, depending on whether we're at the time when they've been published, they may have different number of actual literature citations. But what's really important and the common feature of all of these papers is they're considered to be highly cited papers, meaning they collected in the top one for the number of scientific references in the field. Why is that important? Well, in case if you're looking for a review paper, you would really like to be able to review the paper which is the most impactful, which gathered quite a few reviews, because very likely the people who have cited this paper quite a few times, they really enjoyed it. It was very useful for in their research. So in this particular case, I'm actually going to click on this paper now, since we're reviewing Web of Science. And now when I clicked on this record, there is quite a bit of additional information that popped up. I can read my abstract, so I can quickly skim through what's been discussed in this abstract. I see the list of the authors. So another cool thing which I can do here, I can click on the author, and the Web of Science is going to spill all the records associated with this particular author. Oh, it actually didn't. I'm actually surprised. That's what I would that's what I would normally expect to see. So I'm surprised that it didn't work. So because it's really supposed to be giving me these papers. Let's try it again. No, it failed. Well, so bad for the demo, but this is what we normally expect. We expect to see the papers associated with this particular author. You can also do some other things, like for example, you can look at the papers which have been cited by this review. So again, if I'm going to click on this item here, it's going to list all the references, and I will be able to access these references. So if there is something interesting with relationship to these papers, I will be able to find. Looking at how many times they have that these references have been cited by, I can also get a quick idea at the most impactful, perhaps original research. And there are a few other things which I'd like to review on the Web of Science. So some of the other interesting features here, you can actually click on this link here, which says 360 link to full text, and this is provided through Wayne State University. So once I do click on it, it's going to take me to this window where I can additionally click on full text online, and that's now going to take me to the web page of the journal. However, the way I've gotten here was through the gateway of Wayne State University, and now I can click on the PDF, and I can download and access the PDF of this paper. So, was it tedious? Yes, but I was able to find the paper that I needed, and I was able to get to a PDF through Wayne State subscription, and I was able to search for it in a way that was quite meaningful, because I was looking for a paper that was the paper which was cited in the field that I'm not familiar with, yet I was able to find a rather impactful paper. So what you can do here, you can obviously save a paper. So I'm going to do that. So I'm going to save it on a desktop. I'm going to go, and now it's going to load. So you're actually not seeing it. I'm going to go back. So what I'm going to do here, I'm going to click back one more time. I'm going to close this window. I'm going to go back to this window, and I will review one additional feature of Web of Science, which is quite useful at the time when you're actually going to be writing a paper, which we will be discussing during some next lecture. So here you have an option to export. So I'm going to click on this link, and there are various ways to export. In case if you have account with Web of Science, you will be able to do what we call EndNote Online Export, and that's going to go to your online library, which is quite useful. Or you can click on EndNote Desktop, and here I'm going to choose to export the entire record. A thing is going to happen. It's going to get stored. Did it actually happen? Yes, it did. So here I have this record saved, and what I can do next, I can open this record in my EndNote. So now I realized you're not going to be able to see what I'm doing. So let me actually unclick it and then share the screen again. And now I'm going to share my EndNote program. So this is what happened in the EndNote. This record got exported. I have this saved in the EndNote, and later on during these lectures, we will discuss how things can be organized through EndNote. But the key feature here, we used Web of Science to be able to download the true and correct records to be able to populate our EndNote library. So this is quite handy. As you perform your online search, you can also be quite effective. You can save the searches that you like, and EndNote will provide you now with the features to be able to read through the abstract and some other features, which we will review later. So I'm gonna stop sharing right now again, and now I will switch over to my PowerPoint presentation. Where is that? There we go. So you should be able to see the slides again. I'm gonna open up this screen to full screen. So another search engine is a PubMed. So PubMed is quite useful because it's a different type of a search engine. It's provided through and designed through NIH, National Institute of Health. It is sponsored by the NIH. It is free to use, free to search. You don't need an account. You don't need a subscription for it. It's a fantastic resource. So this is what you would normally expect when you get to PubMed. Now we will do the stop share. We'll do a switch over to Google Chrome, and we're gonna go to PubMed now. So again, this is what you would normally expect if you type, if you Google PubMed, it's gonna take you to this web page. So here we're gonna type the same thing. We're gonna type choline and NMR spectroscopy, and we're gonna perform a search. So here we were able to generate more than 6,000 results, as you will be able to see. Things are kind of aligned here in a different way. In a way, things are done here clunkier than in the Web of Science. However, this is a free engine. Here you can get some papers for free. You don't have to have a institution subscription to be able to access these papers. And again, it's another tool that we use to be able to perform searches for literature. Again, I'm going to click on one of them. Here you will have multiple options. You may be able to access full text through the link. Sometimes free, sometimes there is a free option to be able to access the text because the research has been sponsored through, for example, NIH activities or NIH grants. And as a result of that, the researchers have to share it for free. So again, in a way, this searching is similar to the Web of Science. You can search by the keywords, you can search by the authors. However, some of the functionalities here are lacking, in my perspective, from the Web of Science because you cannot do these fancy features and it's kind of difficult to navigate. But there are some other advantages. And there are some other reasons why PubMed exists. It's quite useful for biological sciences in particular. I'm going to stop share screen. I'm going to go to my next slide. And oh my God, PowerPoint, there we go. So the last resource that we're going to review, it's Google Scholar. It's obviously developed by Google. This is the link for the Google Scholar. Unlike other engines that we've been discussing today, especially such as Web of Science, Google Scholar catches many things. It catches non-peer-reviewed literatures. It catches all kinds of conference abstracts, archives, and so on and so forth. It catches patents. So it's kind of useful and handy from this perspective. So in case if the stuff has not been published yet, Google Scholar may actually have it. Additional features which are quite useful, Google Scholar does not have a subscription, so subscription is not required, it's free to use. It's quite helpful though to be able to have a profile established with Google Scholar because it provides you with some additional features, but it's totally not mandatory. And in my opinion, Google Scholar is very useful in case if you're trying to search papers and literature by the profiles of the scientists, as we will review it. So it's the interface is quite a bit different from PubMed and Web of Science, but it has its own perks and has its own advantages and disadvantages. In case if you are performing search on Google Scholar, and let's say here I typed choline and NMR spectroscopy, that's what I would normally get. So this is kind of the response that I would see. Kind of limited features, but you would be able to access the paper you need. In case if you have a title for a paper and search by a title, you would be able to get the kind of information that you like. So again, the kind of key advantage here, you can just go from Google,